Here we're going to look at topic 77, example 5, interpret a polynomial model. So in science class, Abby mixes a fixed amount of baking soda with different amounts of vinegar in a bottle capped by a balloon. She records the amount of time it takes the gases produced by the reaction to inflate the balloon. And from her data, Abby created a function to model the situation. For x quarter cups of vinegar, it takes t of x equals, and then we have our function, seconds to inflate the balloon. So the x value is the quarter of cups of vinegar, and the y value is going to be the seconds that it takes to inflate. So in question part A, how long would it take to inflate the balloon with 5 quarter cups of vinegar? So we're going to graph this. We're definitely not doing this by hand. We're going to use the graphing calculator. So for y1, I'm going to type in my equation, negative 0.12 x to the third plus x squared minus 3.38 x, missing a number, 3.38 x. Okay, always check your equation, make sure it's typed in correctly, plus 13.36. Okay, so negative 0.12 x cubed plus x squared minus 3.38 x plus 13.36. Okay, so I'm going to hit graph and see what happens. So if a graph looks similar to this, obviously we can't see the whole thing, but what we can do is we can either change the window or we can just go to our table. So I'm going to go to the table and I'm going to start with 0. So 0, 13.36. We don't need this to be perfect. We're just going to pull a couple numbers to get the shape of our graph. 1 is 10.86. So 1 and 10.86 will be somewhere around here. 2 is 9.64. So that'll be somewhere here. These numbers are decreasing, so we're going to look to go 3 is right under 9. So somewhere in that area. 4 is 8.1. So it'll be here. 5, 6.46. So that drops pretty quickly. It's going to be somewhere in that area. And 6, 3.16. So somewhere here. And then 7 is negative 2. So that's, we know it's going to cross somewhere in this range down here. Okay, we don't know exactly where. So let's just draw a little sketch of this. We'll connect these points. It's going to look something like that. If we go back to our graph, it's kind of accurate. So it'll do. All right, so the question, how long would it take to inflate the balloon with 5 quarter cups of vinegar? So we're looking for 5. That's going to be this point here, right? We already graphed that. So at 5, that was 6.46. Remember, the y values represent our seconds. So part A, we're just going to use the graph. We don't have to do any other work. How long would it take to inflate the balloon? We would say about 6.4 seconds. All right, pretty simple, pretty straightforward. Not too much trouble with that. Okay, yeah, I'm good with that. Just go back and make sure I type this in correctly. Plus x squared minus 3.38x plus 13. Yeah, so we're good. All right, from there, we want to look at part B. What do the x and y intercepts of the graph mean in this context? Do those values make sense? So in part B, our x-intercept. So x-intercept is somewhere in like 6.7, 6.6. We don't know exactly where it is. Sorry, but which means that that would be 6.6 cups. Then that would inflate in 0 seconds. So the x-intercept tells us in 6.6 cups. I'm struggling here. 6.6 cups would inflate in 0 seconds. Obviously, that makes no sense. So we'll get to that in a second. The y-intercept tells us in 0 seconds. We have 13.2. If we use no vinegar, so let's rephrase that. So if we use 0 cups, it would inflate in, what was it, 13.36 seconds, which again makes no sense. So do those values make sense? No. The intercepts are not realistic. We'll just leave it at that. And that's all I'm really going to say for that one. If they give you the function, one of the main things you'll have to be able to do is interpret the information, but the graphing part and finding certain values should be fairly simple using the graphing calculator. So make sure the equation is typed in correctly. Be careful with your negative signs. Oops. I don't know what's going on here. So let's clear that. Make sure you're using the negative signs appropriately. Be careful with your exponents. Be careful with your variables. Anything like that could throw your entire graph off. So if you're careful with it, you should get the correct answer.